Hello! Today I'm going to show you how to program the Mandelbrot set in Unity. So, to start off, we're going to create a new project. We're going to name it Mandelbrot. And since the Mandelbrot set is a picture, we'll just go with the 2D preset. Okay, now that Unity is opened, we will be drawing the Mandelbrot set on a blank texture. So we're going to make that texture. Just open your favorite editing program. It can be as simple as Paint. And we're just going to make one big picture. Let's make it 5,000 by 5,000. And we're just going to fill it with a blank color. So I'm going to just fill it with blue. And just save that. Okay, now I'm going to create a resources folder and import it into there. Now that we've imported it, all we're going to do is make the pixels per unit a bit bigger to make sure it'll fit on the screen easier. Very important is to enable read-write since we're going to be changing this texture. And I guess we might as well reduce the compression because we're going to want all the detail we can get. Okay, now that we've applied those settings, let's just drag this picture into our scene. We can see the picture. We know that our picture is 5,000 by 5,000. So let's create a new resolution here, 5,000 by 5,000. And now we have the perfectly sized screen here. Okay, now that we've dragged our picture into the scene, we are going to inspect it, add a component, and call it Picture Changer. Now just hit create and add, and let's open that in Visual Studios. To start, we're gonna create a private texture field and just get it on start. So we do this by getting the component of the sprite renderer, which is attached to our image. And then we just get the sprite and then the texture of the sprite. Next, we're going to get rid of the update since we don't need that. And we're going to create a method, a private void color position, which will just take a vector2. We'll call it position. And it's just going to set the correct pixel color to whether or not it's in the Mandelbrot set. For now, all we're going to do is set the pixel of our texture at the position to black for now. So this script will color our Mandelbrot set, but we also need to have a complex number which with we can do all the math to find out whether or not it's actually inside the Mandelbrot set. So to do that, let's just create a new script. We'll call the script complex number. We'll make this a struct, meaning we don't need a mono behavior here. We can also get rid of the start and update. We'll just have a public float for the real part, as well as a public float for the imaginary part. So we've got our numbers. Now we need some actual methods. For getting information about the Mandelbrot set, we'll need to be able to add complex numbers as well as square complex numbers. We'll start with the simpler one, which is just add. We'll have a public complex number, because that's what two complex numbers, when you add them together, you get another complex number. We'll call this method add, and it'll take in another complex number. So this will be real simple. We just have the real part, and we'll add the complex, the second complex number, the real part of that, and same with the imaginary part. Actually, we don't even need to make it a complex number since we're just changing the value of the one we're adding onto. Next, we'll have the squaring method. So we'll just create another public void square. Now it's just going to square the number that's already within the struct, so we don't need to give it any parameters. So the imaginary part will just be the real part squared, so real times real, minus the imaginary part squared. And the real part will just be 2 times the imaginary part times the real part. Now these numbers are going to interfere with each other, so we're just going to store them earlier. We're going to make quick locals, because otherwise the imaginary one is going to change how the second one will be, so we'll just do the math for these first. And there we go. Now we can square a complex number. Next, we're going to actually have the method that checks whether our number is in the Mandelbrot set. To do that, we'll have a public void is in Mandelbrot. Here we'll have 2 complex numbers. The first one will just be constant. So we'll have C, and this will always be the same. And then we have our second complex number, Z. This one's going to be constantly updated, but it will also start out with these values. We're also going to have a depth that we'll check for. We'll just make this an int depth. We'll have our for loop check this many things through, and we'll set it to 50, but that way we can always change it later if we want. And then for every cycle, we're going to take Z and square it. And then we're going to add C to Z. Now, to make sure this doesn't just blow up to infinity, we're going to add a little check here to make sure it's not too big. We know that because the Mandelbrot is always within a dedicated circle of length 2, anything going outside of this circle is going to blow up to infinity. So we will need to check to make sure it's in the circle or not. To make sure it's outside this circle, we can do a bit of maths. We can take the real part of Z and square it. And then we just add the imaginary part and square it. And then we take all of this and we take the square root of it and we check if it's outside of this radius. And then we can do the rest of our stuff. Now, square root is not very performant, so since we know we're always going to be looking at the radius 2 here, we can square both sides, which will get rid of the square root here, and it just changes our 2 into a 4, and then it'll be more performant. Anyway, so back to here, we just check. So if this is true, then we know that the complex number is not in the Mandelbrot set. So we'll actually need to return a value, so we're going to make this actually a bool here. And we're going to return false. And otherwise, after this for loop, we just return true, because it will have passed through. Lastly, to make our lives a bit easier, we're going to create a constructor. Kind of the same way you can create a new vector3 and then give it some values. We're just going to do the same here. So it's going to be a public complex number, taking in the real and imaginary part, and it'll just turn real into real and imaginary into imaginary. There we go. Okay, let's save that and go back into our picture changer. So here we're going to now actually create the complex number and find out whether it's in the Mandelbrot set and set the correct pixel. Now, one thing to note is that this setPixel method only works on the actual image coordinates. Since our picture here is 0 to 5000, this is going to range from 0 to 5000. And of course, the Mandelbrot set only goes from -2 to 2. So we're going to need to do a bit of conversion first. So when we create our complex number, which we'll just call complex number, we'll create a new complex number, and the values we'll give into it are the position.x divided by your texture width Now, this would make the new complex number only range from 0 to 1, but we want it to range from -2 to 2. So we're gonna actually have to take this width and divide it by 4. And that means we get it from 0 to 4. And then we just take 2 away from that. So now we'll have instead of a pixel coordinate from 0 to 1000, we now have a number that goes from -2 to 2. We can do the exact same thing for the y coordinate. So we just do position.y divided by texture.height divided by 4 minus 2. I'm gonna create a little break here so you can read this easier, and I'll also reformat everything. And then all we do, instead of immediately setting the pixel to be black, we check first if the complex number that we created here at the correct position, if it is in Mandelbrot, which will return a bool, then we can set the pixel black, and otherwise we just set the pixel to be some other color, like let's just try white. So our method is complete. Now all we need to do is actually go through every position on the picture, check if it's on the Mandelbrot set, and if so, then we'll just color it in. So to do that, we'll just create 2 simple for loops. I'm gonna press tab twice there to insert the automatic code snippet. We'll change this for X, and it'll go to the texture.width. And then we do another one, except this time it'll be for the Y. Again, just press double tab while you're typing 4 to get this little snippet. Here it'll be texture.height. Okay, and now we just color the position at our new coordinates. So we just create a new vector 2 with the X and Y coordinates. Ah, yes. So you also have to make sure that you are actually applying the texture whenever you do this. So after we did all the color changing, you just hit texture.apply. Let's try that. Okay, we have something weird looking. Now this is not shown up in my testing, so this is surprising. So I noticed something here. These two are actually switched around. So if we switch them around properly and take a save, let's try this out now. That's a little more like it. But as you can see, you can just as easily create some other new fascinating patterns by just switching 2 numbers around. So we can go back into Unity, and the great thing is this apply works for a long time, so you can actually zoom in onto this image even while we're not in the play mode. And you can see here, you can see a tiny little Mandelbrot set over there, as well as everything else. So it's really nice. This is technically the Mandelbrot set, but we're going to do a little more. We're going to add a bit of a halo around it. Because right now we're just seeing whether a number is inside the Mandelbrot or whether it's not. And it'd be cooler if we can get a little information as to how long it took to get there. So that's what we're going to do next. So instead of just immediately checking whether it's in the Mandelbrot set or not, instead we'll turn this into an int so we can actually get some information as to how long it took. So here we'll just return I. And otherwise, we'll return -1 so that we know that it's definitely in the set. When we go back to the picture changer, here we just need to change stuff up a little bit. Here we do if the number is equal to -1, which we said earlier is going to be specifically for the numbers actually inside the Mandelbrot set. We'll just turn it to black. And otherwise, we'll do some special stuff depending on how long it is. First thing though, I'm going to cache this so that way we don't have to calculate it twice. It'll save us a bit of processing power. But I'd also like to make the colors seem a little interesting. So I'm going to go up here and create some new colors. And let's just turn this into a private color array. And I'm just going to pick a bunch of new colors. Okay, I've just arbitrarily chosen some colors here. There's 1, 2, 3, 4, 5, 6 of them. So we'll just put a 6 here. And of course, end it. We'll need to give this a name, so I'll just call it Halo Colors. Now I've chosen these colors arbitrarily. You can actually give proper hex codes if you know anything about colors, but I'm just choosing this as a demonstration. So my idea is it's going to cycle through each of the colors, first red, then blue, if it took 2 steps, yellow if it took 3 steps, and so on, and it'll just keep cycling through it. So we have our colors, and now we just need to actually program it in. So we just take a new color, we'll call it color, and we'll set it to our halo color array, and we'll just take the steps it took mod, that's what this % is, and then the actual length of our array, which is 6 in my case. And then instead of setting the color here, we just switch this up to color. And let's save that and try it out. And there we go. So now we have all this beautiful array of colors. Now, if we wanted to, we could very easily just switch the colors we're using. For example, I don't think the red looks very nice at the beginning, so I'll just move it a bit later. I mean, this is arbitrarily that we're even doing the colors, but I mean, if you want to, you can do something else. I just like it if it looks like this, because then you get a lot of color and it's not just a black and white image. But if we hit play again, we'll see it takes about 3, 4, 5 seconds to load, but then it'll spawn in all the colors. And see, now it's starting with blue instead. And the great thing is we can just zoom in on this image. And you can see there's a lot of detail because this is 5,000 pixels wide. So yeah, that was today's video. I hope you all learned something. If you liked the video, feel free to leave a like. And if you really liked it, make sure to subscribe. That's everything.